So here's a video on p-values and what they mean. Now, I did a short video about how to calculate something called the Spearmans rank correlation coefficient, where you look at the relationship between two variables. Is there a trend? Is there a link? And at the end of that video, I had invented some results linking soil temperature to the number of species found in each quadrat. And we calculated this and we got a Spearmans rank correlation coefficient of 0.67. And I ended by saying that's pretty good. That's positive, so it's showing a positive correlation. And it's quite close to 1. Remember, 1 would be the perfect correlation, and 0.67 is quite close. So I said that's pretty good. But at A level, it's not enough just to say, oh, there's quite a good correlation. You have to actually examine how likely that correlation is to have occurred by chance. Because it's perfectly possible, when you're collecting just a few data points like this, to see a correlation when actually, in reality, there isn't one. Remember, we were taking a sample. That means we were doing a transect and we were taking a little snapshot, collecting data points at specific locations. Well, that snapshot is just part of the picture. If we wanted to, we could go back to Wittering and we could do hundreds, thousands of transects to get many more data points. But all we've got is this sample here. And it is possible that actually our sample is not representative. So what if the black points are the ones that we actually did, but there were all of these other ones out there that we didn't sample? There's no correlation there, but we think there was because we have, just by random chance, happened to pick upon those samples that show a correlation. So it's random, variation, random chance, and we think there's a correlation where there isn't one. Okay, so what we need to do is we need to do something with our statistic to find out how likely this is. So remember, the situation was we had a nice correlation between our two variables. Okay, it looked like that. What we are going to do is we're going to work out what are the odds of that occurring just by random chance. And this is linked to the number of samples that you took. If you think about it, that makes sense, because if you take just two samples, it doesn't matter where you put those 2 points on your scatter graph, there's always going to be a correlation. Positive or negative, doesn't matter. 2 points is going to show a correlation, so that's not very helpful. This is why a big sample size is important. If you only had 3 or 4 points, well, they could be pretty well scattered and you still might think you see a correlation. If, however, you had hundreds of data points and they all tended to show a trend, well, that you can be reasonably sure is a real correlation, because the odds of all of those hundreds points showing the same trend are much, much lower. So what we're going to do is we're going to look at the number of samples you took, and for some of you, you've got 14 different stations along your transect, some of you got 10, it depends how many you did. But we're going to look at how many samples you took, and then we're going to use something called a probability table to work out the odds of your correlation occurring just through random chance. So, you'll need one of these. This is called a probability table. And there are 3 components to it that you need to be familiar with. And the first one is over here. This is where it says n number of pairs. That's just the number of stations you went to along your transect. And we say pairs because at each station you're measuring 2 things. And it might be that you're measuring the number of species and the soil temperature, or the number of species and the wind speed. You're going to choose an abiotic factor, and that's 1/2 of the pair. Okay. Now, in my made-up example from the previous video, I only had 8 pairs. So I'm going to go down to n equals 8. The other thing that you've got on here, in the big box I'm drawing now, these are a whole set of standard Spearmans rank correlation coefficient values. So these are all pre-calculated RS values. You don't need to worry about how those are generated, but you do need to know how to use these. And what we're going to do is we're going to compare R value to this. Remember, R value was 0.67. The last thing on the probability table that you need to be aware of is this bit at the top, where it says probability that your result occurred by chance. And then you've got probabilities ranging from 0.1 to 0.005. Now, what they're doing here is they're using decimals, so that something that's absolutely 100% certain would have a value of 1, something that's 50% likely to happen would have a value of 0.5, but we are actually going to be looking down in the region of 10% to 5, 2.51, and maybe 0.5% there. So we're looking at the sort of more unlikely end. Okay. Now what we are going to do is we're going to take our RS value and we're going to compare it to these ones on here. So I'm going to be looking along the row for my value of n, which I said was 8, and I'm going to be looking at these numbers here and trying to find where my RS value will sit relative to those. So the first number I come along to is 0.5476, well it's bigger than that, then it's 0.6429, it's still bigger than that, then it's 0.7381. Well, my Spearman's rank correlation coefficient value sits in there. So my correlation coefficient is somewhere between those two values. That means I can now get an idea of roughly what the chances are of getting my correlation through random chance by reading up here. It's going to sit somewhere between 0.05 and 0.025. So that means the chance of me getting my correlation through luck alone is between 5% and 2.5%. This is what we would call a significant result. Remember that your null hypothesis is kind of the boring one. There is no relationship, everything's just continuing with no link. So your null hypothesis is the one where there is no exciting link going on. But I just found a correlation, and I've said that the chance of getting that correlation through random luck alone is below 5%. That's so unlikely. I've got to reject my null hypothesis and suggest an alternative. There's obviously a link between the two variables. Now I can start talking about what that might be and how soil temperature affects the number of species. This 5% value here is absolutely crucial. It's the significant threshold. Scientists are always looking for something that is less than 5% likely, because if it's below 5%, that's less than 1 in 20 times it's going to occur by random chance. And they've kind of set that as the standard. If it's below that, it will be significant and you can reject your null hypothesis. I hope that was useful.